Okay, Trig kids, we are back with the second part, part B of section 7.2. Now, this encompasses the last 5 problems of this section for you for 7.2. The next couple, the problems 8 and 9, they are those step-by-step ones where you have to fill in the blank. Now, we are verifying co-function identities, but we're using the addition and subtraction formulas, the sum and difference formulas that we talked about in the first section. Okay, so here's the problem I have. Tangent pi over 2, whoops, not plus u, I actually have minus u, let me change that, equals cotangent u. Okay, tangent of pi over 2 minus u equals cotangent u. Now, u, they're just another variable. It could be x, it could be whatever, it doesn't matter. But we're actually, once again, going to be working on the left-hand side and trying to use our sum and difference formulas to verify that tangent of pi over 2 minus u reduces down to cotangent of u. So let's first, like we typically did back in section 7.1, let's rewrite tangent as sine over cosine. So this is sine of pi over 2 minus u over cosine of pi over 2 minus u. Okay, so again, just filling in the blanks after we substitute in sine over cosine for the tangent function. Now, if we're going to be using the sum and difference formulas, we need to remind ourselves what those are. Okay, so let me write those up here so we can reference back to them. So let's first talk about the sine. Sine of x minus y, we're only using the difference ones here, so that's all the ones I'm going to write, is sine x cosine y minus cosine x times sine y. Okay, so sine x cosine y minus cosine x sine y. And then cosine of x minus y is cosine x times cosine y plus sine x times sine y. Okay, so I've got the cosine, the difference formula underneath the difference formula of the sine function. Okay, now let's use those formulas to rewrite the left side of our equation here. So I'm going to split out the sine and the cosine on top and bottom using those formulas. So here we go. So this gives me sine of pi over 2 times cosine of, not y, that would be cosine of u, pardon me, minus cosine pi over 2 times sine u. Now that's just the numerator, okay? Sine of the first times cosine of the second minus cosine of the first times sine of the second. All over, use the cosine formula down below. We've got cosine pi over 2 times cosine u plus sine of pi over 2 times sine u. Now remember, you can't go canceling stuff top and bottom because you don't have any one thing factored out. So don't be thinking you can start canceling. You can't. What we can do is replace the sine pi over 2 and cosine pi over 2 with those values. So if you remember, pi over 2 is 90 degrees. Sine of pi over 2, sine, remember, is your y-axis. So sine of pi over 2 is going to get replaced with a 1. Cosine of pi over 2, again, cosine is your x-axis. At 90 degrees, that's a 0. Okay? So we replace what we can with ones, and of course the zeros mean that these are all going to just go away because 0 times anything is 0. So now what we're going to have left then is just cosine u over sine u. Now, cosine u over sine u, we know, is the cotangent. And again, that is the same thing that we were trying to verify. Okay, so that is number 8. All right, let's move on. Now, my number 9 looks like this. Sine of x minus pi over 2 equals negative cosine x. Now, once again, we're going to be working with the left-hand side. We're going to be using our difference formula for sine, and I just wrote that on the previous screen, so I'm not going to write it again. But let's quickly refer back to it and just look. So sine of difference formula is sine of the first times cosine of the second minus cosine of the first times sine of the second. So let's use that here on the left-hand side. So we are going to have sine x times cosine pi over 2 minus cosine x times sine pi over 2. Now, once again, our cosine and sine here, cosine pi over 2 gives me a big fat 0. Sine of pi over 2 is 1. So all that leaves me with is 0 minus cosine x, which is just negative cosine x. Okay, pretty straightforward, I think. Now, next one. Here's my number 10. I have cosine x plus y plus cosine x minus y. And I'm trying to verify that that equals 2 times cosine x times cosine y. Now, once again, I'm just going to focus on the left-hand side. Okay, so let's remind ourselves once again of our formulas for cosine. And it would help if I could spell. So cosine of x, let's do the plus one first, plus y equals cosine x times cosine y minus sine x. Not sure what happened there. Minus sine x. Why is it? Sine x, sine y. Now remember, the plus and minus on cosine are kind of backwards. So this plus goes with the minus on the right-hand side, but if there's a minus in the middle, then it turns to a plus on the right-hand side. Okay, so that's my cosine formula. So let's use that then for the left-hand side. I'm going to put this one in red, and I'm going to put this one in blue when I expand it. So first, my sum. I've got cosine x times cosine y minus sine x times sine y, and then plus. Now, in blue is my difference formula. So I have cosine x times cosine y plus sine x times sine y. Okay? Now, notice that these are like terms, okay? But they cancel. One's a minus, one's a plus. So all I'm left with then is cosine x cosine y plus cosine x cosine y. Well, that gives me two of them. 2 cosine x times cosine y. Now remember, on problems 10 and 11, they just give you that box that you have to type in your answer. So do the best you can. The same kind of deal that we had in section 7.1. Okay? So let's do number 11. Okay, we've got cosine x minus y times cosine of x plus y. We're trying to verify that it equals cosine squared x minus sine squared y. Okay, now this one gets a little funky. So first I'm going to use, I'm just going to focus once again on the left-hand side. I'm going to use my sum and difference formula. It's not going to write them again. But this one, let me write out, I'll write it out in red. We've got cosine x times cosine y plus sine x times sine y. Okay? And then this one in blue, we've got cosine x cosine y minus sine x sine y. Now, that's a binomial times a binomial. Okay, so actually we're foiling this. Okay? We are foiling those two things together. Now, it's kind of like the difference of two squares in reverse. Okay? So this is actually cosine x cosine y squared minus sine x sine y squared. Okay, so that's going to give me cosine squared x times cosine squared y minus sine squared x times sine squared y. Now, here's where it gets a little tricky. I actually had to look at this for a little while. I was looking at the right-hand side of the original equation, and I thought, okay, they got rid of the cosine squared y, and they got rid of the sine squared x. So I'm actually going back and substituting in, remember your trig identity. I've written it, feels like a million times already, but sine squared x plus cosine squared x equals 1. So I'm going to substitute in here, in place of this cosine squared y, I'm going to substitute in 1 minus sine squared y. Okay? Same thing with this sine squared x, since that's the part that's missing on the original equation. I'm going to substitute it in, and again, I've got to use the same variable. I'm going to substitute sine squared x by 1 minus cosine squared x. Okay, now let me rewrite the other parts of this. And then I have to distribute. Okay, so if you remember, I've got to distribute this to both of those terms, and I've got to distribute this to both of those terms, along with the negative. Don't forget the negative on the second one. So this is going to give me cosine squared x minus cosine squared x times sine squared y let me get some more boardroom here, minus sine squared y plus cosine squared x sine squared y. Okay? Now, notice that these two terms are going to cancel each other out. The minus cosine squared x sine squared y and positive cosine squared x sine squared y. So all I am left with then is cosine squared x minus sine squared y. That should be my final answer. And that is what we were trying to prove. So that's my verify. Okay? All right, one question to go, and then we are done with section 7.2. So last problem, number 12. I have cosine of arc sine of 1/2 plus arc cotangent of root 3 over 3. Now, remember when we have arc sines, arc cotangents, we are trying to come up with the degree measure that yielded us a 1/2 or the degree measure that yielded us the root 3 over 3. So we have to find the degree. Okay? So let's look at these separate here. If you look on your unit circle, okay, what degree measure gives you 1/2 for sine? That's what we're asking ourselves. Okay, what degree measure gives you 1/2 for the sine function? Now, that would be 30 degrees. Remember, sine is your y-axis. So that is 30 degrees. So this is going to be, that first part, we got 30 degrees. Okay? Now, the cotangent. Let's kind of talk about this for a little bit. Cotangent's a little weird. Okay, remember? So cotangent, the inverse would be the same thing as the inverse tangent of 3 over root 3. Remember, cotangent is the inverse of tangent. So if I flip that root 3 over 3, I can make it an arctangent function instead of arccotangent. So the arctangent would be a 3 over root 3. Now, if I simplify that 3 over root 3, if I rationalize that denominator, okay, if I multiply the top and the bottom by a root 3, then this is going to yield me arctan of just root 3. Okay? Because you're going to have 3 root 3 over 3, and the 3's are going to cancel. So arctan of root 3, that gives me 60 degrees. Okay? So this part would be 60 degrees. Now, and you can think about this. Remember, tangent is sine over cosine, so you can kind of think through that a little bit. But arctan of root 3 is 60 degrees. So this ultimately gives me cosine then of 90 degrees. Cosine of 90 degrees, remember, that's pi over 2. That's straight up and down, or straight up, I should say, not down. On your unit circle, cosine is your x-axis, so this is 0. Okay, that's your answer, is 0. All right, that concludes the notes for section 7.2. I really hope that these notes are coming in handy for you. Please let me know if they're not. I have spent quite a bit of time doing them, and if nobody's watched them and they're not handy, I'll stop. But thought I'd give it a try. So good luck.